Welcome to The Tech Between Us, a podcast that takes a look at the past, present, and future of some of today's most influential technologies. Hi, I'm Raymond Yin, your host and Director of Technical Content at Mouser Electronics, a leading global distributor of semiconductors and electronic components. Today, we're going to revisit the topic of 5G, though in a slightly different way. Last year, in our conversation with Dr. Mathieu Bloch from Georgia Tech, we talked about how 5G has the potential to revolutionize key industries such as manufacturing, logistics, transportation, and healthcare. For more technical information on 5G, I encourage you to listen to our previous podcast or read our content at mouser.com/empowering-innovation. For most of us, cellular data is used for social media or playing games or streaming content. Global enterprises, however, often rely on wireless data for mission-critical applications, and many are now turning to non-public or private cellular networks for these crucial operations. As the name would suggest, private cellular networks are owned and operated by individual corporations rather than carriers such as Verizon here in the U.S. There are already a number of these installations out there using LTE or 4G, which are now giving way to new 5G networks since 3GPP Release 16 laid out definition and details of these non-public 5G networks and then further refined the concept in the recent Release 17. Market research firm Gartner predicts the installation of private 5G networks will grow at about 35% over the next several years as corporations begin to take advantage of the capabilities of 5G. To discuss how these private 5G networks are being used by corporations across the globe, we're talking today with Gilad Garon, CEO of ASOCS. Gilad, welcome to The Tech Between Us.
Thank you, Raymond.
Gilad, can you briefly introduce yourself and tell us a little bit about what ASOCS does?
Sure. I'm Gilad Garon, and I'm CEO of a company called ASOCS. ASOCS enables 5G private networks for enterprises, mainly focuses on this industrial use case that, of course, we'll talk about more broadly today, and has been around in business for around 18 years. We've got offices in 4 continents and about 100 employees.
Outstanding. So needless to say, you've been around private 5G or private networks and 5G networks in particular for quite a while.
Yes, we've been lucky to follow and in some cases even evangelize some of these concepts that look fairly trivial these days, all the way back from about 10 years ago when virtualization of networks was started to be a topic in our industry. So we've had the luxury to follow the evolution of this trend and topic throughout this decade.
Terrific. So ASOCS has grown with the advent of networks. And Gilad, can you briefly define what a private 5G network is, or a private network in general and a 5G network in particular is?
Sure. Well, the most obvious definition of a private network is that network is privately owned. Unlike public networks, your general operators and carriers, although they can be private, they're just more regulated and they have to adhere to many different regulations and standards, while a private network is something that is in the control of an organization typically. Before 5G came into place, the most obvious 4G or other cellular private networks were more in isolated areas such as oil rigs or mines. Or, I just recently read about a private network that's going to be established on the moon. So places that were less obvious. So that's one key definition. But I think the more perhaps interesting definition to define private networks is that a private network enables an enterprise to control its destiny. He can make the decisions about capacity, about performance, about how he wants to use the network, evidently in a much faster and a non-regulated way, if you will.
Okay. So private network is quite a bit more than simply a company going in to a carrier and leasing, a specific segment or a series of base stations. The company actually goes in and, based on their business model, actually puts in their entire network from pretty much from scratch then.
That is true. I mean, again, there's several sometimes confusing definitions about private networks. And in 5G, to make it even more complicated, there's the ability of an operator to offer a differentiated service through a technology called network slicing. But in general, when you're sitting in environments which are, for example, inside a factory, or even in a campus environment, you tend to want to eliminate the risk of being managed by an external entity, and you pretty much want to own your own network. Again, it doesn't have to do necessarily with the ownership aspect. It could be leased from service providers or system integrators, but definitely you want to control it. Perhaps adding one more layer to this definition is the issue of spectrum. And as we all know, public networks have been around, for 40, 50 years, and their main asset other than their infrastructure and perhaps their customers is the fact that they own a license on a specific spectrum, often paid quite a lot of money for. In 5G private networks, that spectrum policy changed dramatically, starting with markets such as Germany and then moving to other segments of Europe and Asia. And perhaps we will talk a little bit about the United States with its CBRS band, but basically it enables now for an enterprise, as an example, a factory, not just to manage a network, but also own his own localized spectrum. And that's really a second major disruption that is enabling the 5G private network. So it's technology, it's need, but it's also spectrum and government policies that have all aligned in order to create this trend. So that's probably, without one of these three legs, this industry would not grow as fast as it is.
So you mentioned spectrum. So is the spectrum for private 5G networks using the same spectrum that the public network is using, or is it a completely different set of bands within the overall RF spectrum?
In general, it's in similar bands, but it's a different range. Just to give you an example, in Germany and in most of Europe, the favorite band that was allocated by governments is 3.7 gigahertz. But you would find the operators at 3.5 or 3.4 or 3.8. So it's near, but it's still separate. In Asia, the favorite bands are in the area of 4.8 gigahertz. And in the United States, with the CBRS band, it's in the area of 3.5 gigahertz. So it's still in this so-called C bands, but it's definitely specific and bespoke for the industrial use.
Okay. So it really gives the enterprise customer, like you mentioned, some complete control, spectrum-wise, capacity-wise, build-out-wise, over their communication infrastructure at these large facilities that are all over the world.
That is correct. And this is probably why, finally, very traditional industries, as we know, such as industrial shop floors, which tend not to be the biggest risk takers on the planet, are willing to entrust some of their, critical communication aspects to cellular. Because no matter how much carriers and other organizations were aiming to convince them that they would get service that would meet that critical needs, they were not convinced. And to be fair, in certain cases for good reason, because as we know, internet links are reliable most of the time. But industrial facilities, government facilities and logistic facilities cannot settle for most of the time. And in order to ensure all of the time, you really need to be on-prem. You need to come with a dedicated approach to the way you cover private networks.
Right. Like you mentioned, this kind of goes back to, a company owning its own destiny and not wanting to put, the 24/7 operation of a complex factory floor in the hands of a public network. They come in, they own it, and if something needs to be done, they have internal resources to be able to solve those problems immediately on their schedule rather than on the carrier schedule.
That is true, but that is also where the other part of these networks is so important, and that's the ITization or the softwareization of these 5G private networks. Because at the telco era, if we can say so, you can still bring in a telco engineer who would open up the dedicated room in the factory and manage the equipment there. But if you want an enterprise to manage its network, it's got to be done in the tools. And I'm not just talking about interfaces like a cool GUI, but he really wants to manage and build up and upgrade and maintain his network like any other IT service. Because at the end of the day, most factories or most enterprises have IT department. They don't have a telco department in place. So they need to manage 5G as yet another resource, and this is where the other revolution that came into place is so valuable. The fact that now I can deploy and manage a 5G private network using, for example, VMware tools or Google or Microsoft. If I forgot one of the cloud providers, please forgive me. But basically, you can manage it like any other IT or even cloud resource. And that's the other inventive step, which is so crucial. Because if I still need to talk and operate in dedicated equipment, then my adoption and my acceptance to this technology is probably not going to be as fast as if people come to me and say, hey, you can now manage, but you can also upgrade and maintain your network in a software fashion. Right? The same way you manage storage, the same way you manage your security elements, etc. And that's the other revolution which is coming in with very strong force from technology vendors, cloud vendors, system integrators. And this is one of the reasons probably that you're getting, maybe 10x or maybe 100x more coverage than you would on industry, which at the end of the day is very specific, right? So now the industrial shop floor has become the center of attention for all these technology companies, because that's really where this 5G innovation is happening in a big way. It's not happening on your public network.
Supporting frequencies up to 15 gigahertz, compact 5G millimeter wave RF flex-to-board connectors from Molex deliver maximum PCB space savings. They also feature EMI shielding, robust mating, and flexibility in pin assignments for power and high-speed signal, all resulting in greater design versatility over a wide range of applications. To learn more, visit mouser.com/Molex.
I know we have done, various pieces of content, videos, articles, talking about how 5G will revolutionize the shop floor through, with robotics, with automation. And, what you've been talking about is essentially just being able to combine all the, whether we call it IT resources, cloud resources, communication resources, into a single, for lack of a better word, thing that is managed from a single location that an enterprise can see at a glance, whether if there are bottlenecks, if there are issues, but also more importantly, where they do need to upgrade, where they do need to invest.
That is true. But as you mentioned, now that I've got this center of information that on one side has input from my wire and my wireless network, but I also have access to my management software, I can now really start creating innovation in a fast way. So, for example, AI software. There's been a lot of discussions about AI software, and the adoption of AI software in factories has not been as fast as people has perceived. And one of the reasons was that, at the end of the day, most of my sensors and applications in my factory are connected to specific applications. So adding AI is not as simple as it may seem. But if I'm adding a new layer of connectivity, and in this example, let's start with the classical robot who is connected now through a new network, 5G in this case, to my data center, then adding an AI layer on top is extremely simple. And then I can create a new innovation in a much faster pace, because as long as my devices and usage was all wired in a sense, not just the physical wire, but the output of the information went to a specific software, it was very difficult to start creating general AI observations. And if I may jump to an example that may help prove that point.
Sure, absolutely.
So we had a project a year and a half ago in Taiwan. It was actually one of the first projects in 5G private networks. And in that project, the application was extremely simple. It was about connecting 5G to an existing optical scanning machine. So I said, okay, why do you need it? That machine stays put. It's not mobile. It does its job. And the idea, the theme was simple yet brilliant. They said, look, the information that this optical scanning machine creates goes to a specific software that is only trained to check something. Some deficiencies or faults in the process.
Certain errors, certain positioning, but very limited in scope.
Correct. And all we're going to do now is we're going to take another lane and take those same exact pictures and move them to an external AI software and see what happens. And guess what? Within a day, literally a day, they've managed to improve yield by about 7% because that AI software that had absolutely no prior information about what it was finding found faults in another section of that card. So that is a very surprising way, but once you think about it, it's fairly intuitive, of this new lane of information created through 5G. Perhaps another example of something which is a little bit more recent was connecting a moving robot to AI, and that robot was basically out there to check for leaks in a tank that creates, that manufactures or distills beer. Okay, so, 5G is even in the beer business. And this robot had an application where it was looking for certain leaks, but then they discovered they can also use that information in order to find other hazards in the area. So this new lane of 5G can come as an additional layer, not as a replacement layer in a factory. And I think, Raymond, that's, another lesson learned that we have seen and, humbly learned in the last 2 years. One of the biggest mistakes of new technologies that tend to be sometimes even hyped to a certain point is their aim to replace everything. And when you get to a factory with a very confident approach saying, hey, all these things that you have done before, they've been wrong, we're going to change the way you do business, that's not necessarily the best approach. But if you say, hey, we're going to add another layer of information, fairly painless for you because it does not require you to rewire everything and revalidate everything that you've been doing in your SCADA networks, but just another layer of information, resistance is lower and frankly, ROI is quicker and easier to show.
Right. And, like you said before, the industrial sector is notoriously resistant to change, to new technologies. And so rather than going in there and ripping up everything that they've put in to drop in a new system, a new network, it sounds like 5G is able to adapt to their current networks, enhance the communication, enhance the control, and yet build upon what they have rather than completely replace what they have and then having them to do qualifications and whatnot from scratch.
That is correct. Perhaps in other industries, logistics is probably another center of attention for many of the 5G campaign videos, right? Everybody always shows those little robots and potentially drones flying around in a logistical center. And that is actually something we are seeing. So in logistics, 5G can truly dominate all other lanes of communication, because in essence, a logistical center is one big cube of real estate at the end of the day, right? So you can create great coverage with very little interference and free your machines from cables. And one of the misconceptions, when I saw those robots who were driving around in logistical centers, I didn't really know that essentially they are wired. That means they're still reading information on the floor so they can move around. Not everybody knows that. At least I didn't. And what 5G did there, it actually enabled these robots to move around in any vector, including up and down in the drone case. And that's a major change in logistics because for me was an amazing fact was that logistical centers, although they're operating in a cube, they have lanes, right? They have very clear lanes of where they want to stock and pile stuff. And when that lane breaks, because there's pallets who are just shipped off, the whole operation needs to somehow change. But if you have a 5G or a secured mobile network with a lot of video there, then this shouldn't matter. You can reshift the whole way in which your storage is being set according to specific needs or the specific merchandise that goes there. So in logistics, you can actually physically see the way wireless, or in this case 5G, is changing literally the way the operation looks like. In a factory, the change is perhaps a little bit more silent, but you can see it at the end of the day in the numbers.
Mm-hmm. And that's one trend that we're seeing as well is, the 5G is enabling true autonomy on a warehouse, logistical floor, as well as a factory floor. And to your point, the robots are no longer governed by tracks and marks on the floor. They are truly autonomous. They can go where the work is. They can, if something changes, with 5G and, the control that you get with 5G, we're seeing, the robots being retasked real time to different functions.
That is exactly it. That is the power of mobility when it comes in a way that an enterprise can manage. Because as long as enterprises didn't feel safe in their ability to comprehend and control these technologies, they were extremely reluctant at mission-critical operations to that network. So that kind of ties into where we started with these definitions, but I think it makes it clearer and clearer. We didn't talk a lot about issues such as safety. And
and that's funny that you mentioned that, because that's actually going to be my next question is, do your customers, is security, is safety, is that one of the reasons that they're putting in 5G and especially private 5G networks?
As a second step, I would say, I want to tell you a story that would make it perhaps interesting. As we said in the beginning of this journey a few years ago, when 5G technology providers were eager to replace everything, there's a famous story about that red button, right? Every factory has a red button that if you press, something violent happens, a machine stops or,
the world shuts down.
The world shuts down. And eager salespeople were saying, hey, we'll use 5G super low latency to move these red buttons into cellular. And of course, that created a lot of skepticism in the eyes of security and safety managers. So luckily, designers of 5G networks and their applications realized that's not the safety we want to try to advocate for. The safety that we're trying to say is, again, how do we use vast amount of video and AI to improve safety? And naturally, COVID was one of the speeding factors for these safety measures. And it started with the trivial, measuring distance between employees, and which is, one type of safety. And now it's moving back to collision, making sure employees are not exposed to severe temperatures by using video, not necessarily just sensors. So sensors have been around in industry forever. And again, we have no intention of replacing them. But when you add a lot of video with AI, you can create faster alerts in real time. And, We didn't talk much about the way we define Industry 4.0, and there's many a definition. And, in technology, cellular and wireless have been collecting data in enterprises forever. I think what makes Industry 4.0 more interesting, and specifically with 5G, is that you have enough time to act on that data in real time. So it's not just about collecting information and then being able to do a post-mortem interrogation of a safety event, but you can actually be so fast that you can prevent the event to even happening. And this is a great example of 10 millisecond round-trip latency. What does that mean? Why is that even important? It's important in a case where you can actually prevent an event that happens in half a second to occur. That's a big deal. If it's just about, faster video to watch, to play games, I'm sure it's very important to gamers, but it's probably not as important to the rest of us, right?
Right. But to avoid, collisions between two robots, or even worse, a robot, an autonomous robot on the factory floor and, a factory worker, that's really when that latency and the reaction time becomes important.
That is absolutely true.
And that to me is just the power of, putting things at the premise, and, whether it be, edge computing or, and using 5G for the ultra low latency.
True. Again, as you mentioned, from a technical perspective, and we didn't talk a lot about, the governing dynamics behind that network, is absolutely the fact that with virtualization, you can actually build a whole network on-prem and astonishingly small footprint and cost. And one of the examples, although it's not directly linked to my piece of software, which runs the radio side or the RAN processing side, is this so-called packet core. And, 30 years ago, I remember packet cores and operators were as big as a current Amazon logistical center. They were huge, and they cost hundreds of millions of dollars. And today, you can deploy a pure software packet core on a laptop computer. That's how small it is. So a few cores, a few Intel or AMD or even an NVIDIA GPU core inside a server is sufficient real estate and hardware to run a 5G network. And that is another key revolution, because now I can really make it accessible. So once that core is there, I can shorten the round trip to the numbers we mentioned. So that's yet another revolution that happened because of edge, because of virtualization, and happened roughly at the same time of 5G.
Right. So these networks are no longer, strictly for, ABB and large manufacturers. They can be scalable down to a single small operation that just wants more security, wants more efficiency out of their network.
That is correct. And you mentioned logistics. And I'm not a great expert in logistics, but the same thing happened in logistics, right? You had massive centralized logistical center, but the trend now is to have a small logistical center at the back of a Walgreens or a 7-Eleven, right? So that qualifies for a logistical center in my books. And if you want to have tens of thousands of these mini 5G networks for that kind of footprint, then you really need to lower the complexity, the cost, the footprint to a point where it's accessible at that level. And the technology enables that. So right now we're in early days. Everybody wants to show his big wins on the big brands, but I personally and my company's business plan believes that the real scale happens once you get to that mid market where enterprises that have multiple chains of logistical centers can afford, not just from a cost perspective, but from a skill set perspective, to manage these 5G private networks. And then we will see the true implications on our day-to-day lives, not just ROI of factories or logistical centers.
So that's where you really see the future of 5G, and specifically private 5G, is not so much the increasing capabilities at these huge centers, but moving that capability down to the next tier of enterprise where, they're not a Fortune 100 company, but the next level down, and, being able to scale efficiently and with sufficient ROI to give those companies the capabilities of some of these larger enterprises.
That is true. We've always said in the cellular industry that the goal of 5G was to create a network of networks. It was just physically impossible to do it from unit economics and technology accessibility during the 4G era. So we've seen there are some smaller scale cellular networks, but they were usually used for small nascent applications, such as, in a stadium, you would have that small private network to manage some of the operational staff. But they didn't manage to really break the way operations are done because they were so pricey and so bulky that at the end of the day, they were at the hands of operators. And operators have great advantage and skill in building nationwide networks. They tend not to excel in building very small networks, which frankly for them as an operational perspective are more cost centers than anything else. So the whole mindset of the industry had to change. And as we said, luckily, it's falling in the same trends of edge cloud, virtualization, AI, augmented reality. All these major trends can only really happen if you have a controlled environment. I mean, think about it. We've been talking about autonomous cars, and autonomous cars were supposed to be the use case for 5G public networks. We all know that's going to take decades, right? Because of the complexity of the regulation. But if I have autonomous vehicles driving in my logistical center in private networks, I can deploy them today. That is the fundamental difference, perhaps, again, going back to the beginning of the conversation, between the speed of innovation that you can create in your own 5G private network over something public.
Magical things can happen when a single enterprise, a single mindset owns the network and is solely responsible for the network compared to the public network, which, you've got government entities, regulations, you've got public corporations all involved in trying to manage and to regulate that whole industry.
Absolutely. And, if you look at more geopolitical, we strongly believe and we've advocated, and we're very happy to see that this is happening. Governments are now literally measuring their quality of, being open to industry a lot by their 5G policies. By enabling the spectrum, by enabling cloud infrastructure, by making sure fiber gets not just to the home, but to the factory. And these things do matter. And as we saw, yes, it did start with one of the biggest industrial hubs in the world, which is Germany. But it was very nice to see how in the last 18 months, this has been moving very quickly across all the industrial countries. And in fact, it's hard for me now to even think of one or even two countries that don't have those policies now in place. And that is something that 2 years or 3 years ago was almost at the point of being unrealistic.
Right. So the world is coming around.
The world has to come around, right? We have to, companies need to be better at what they do. They need to be more localized. Supply chains need to be short. It's not a secret. The last few years have exposed some of the weaknesses of having very long supply chains. And now you got to be...
Absolutely. I think we're all feeling it.
Right. And now you want to be closer to your customers. You got to be, you want to have the ability to adapt products faster and cheaper. And connectivity is not the only factor, but it's definitely an enabler to all these new usages and services.
Gilad, I want to thank you so much for being with us on The Tech Between Us and sharing your insight on 5G private networks and why they are proliferating at such an incredible rate across the globe. Once again, we're seeing it, we've talked about robotics, we talked about logistics, but you had previously mentioned, healthcare and all these other industries where you're seeing a lot of growth and proliferation. And I really appreciate you being here and kind of helping us understand why that's happening.
Raymond, it was my pleasure.
We hope you've enjoyed this episode of The Tech Between Us. Remember, this podcast is just one part of our original and ongoing content series, Empowering Innovation Together. You can find videos, articles, and more on private 5G networks at mauser.com/empowering-innovation. And don't forget to join us for our next episode when we talk autonomous mobile robots.